Today we are going to look at fits and tolerances. The meaning of fits first. When there are two parts and if you try to assemble them, fit is actually the relationship resulting from the difference between their sizes. As mentioned earlier, for various reasons, the parts will be provided with some tolerance. That is, some deviation from the basic dimension will be permitted. The difference in their tolerances will result in a fit. Basically, there are three types of fits based on the limits on the shaft and the hole. One is clearance fit. So here you can assume shaft as the internal member and the hole as the external member, right? So when the size of the internal member is smaller than the external member, we get clearance fit, right? That is, this is due to the positive clearance. Okay. So in case of interference fit, which is the opposite of clearance fit, you have a negative clearance between the mating parts. So the internal member, the shaft, is larger than the external member. So the naturally you might get a doubt that, well, when the size of the internal member is larger than the external member, how can we get a fit? See, here you should not be misled by this word larger. See, when we say the size of the internal member is larger, it is larger only by the order of few microns in comparison to the basic dimension. If the basic dimension is in size is in millimeter, the tolerance will be less than 100 microns. So where you may have to apply a little bit of external pressure, right, to assemble the two parts. So such fits are called interference fits. Then transition will provide either clearance fit or interference fit based on the tolerance value. So probably when we take up problems, you would be able to feel these three types of fits. And in fact, you will deal in detail about the different types of clearance fit, interference, and then transition fits in your next course, metrology and then measurements. So we have two types of systems here for specifying the tolerances to the shafts or the hole to get the requisite fits. So one is the hole basis system and the second one is the shaft basis system. In case of hole basis system, the basic size of the hole is kept as reference, and the different clearances and interferences are obtained by associating with various shafts. Okay. So that is what the size of the hole is, the basic size, right? It is denoted by capital H, so it is case sensitive. So the advantage of hole basis system is that you can always get the required dimension by using a standard drill or reamers, whereas in case of shafts, you can get it by turning it to any dimension. So that is why we always use hole basis system, right? Now let's see how a hole basis system is represented pictorially. So this figure shows the tolerance zones of hole and the shaft. So for better understanding, let us really look into the figure from the lecture 2. So here we have a hole and a shaft assembly. Like in the side view, you can see clearly the tolerance zones of the hole and as well as the shaft. On the right side, you can see that the shaft can easily move through the hole, which means that there is a positive clearance. So on the right end, can you see the tolerance zone of the hole and the tolerance zone of the shaft represented in two small rectangles, right? So when the tolerance zone of the hole is well above the zero line and similarly of the shaft is well below the zero line, we have a clearance fit. So the same will be used here. In this figure A, right, the tolerance zone is touching the zero line, whereas the tolerance zone of the shaft is well below the zero line, which means we have a clearance fit. Coming to figure C, the tolerance zone of the shaft is well above the zero line and off the tolerance zone of the hole. So here we have an interference fit. We need to apply external pressure to create the fit. Coming to figure B, we have a combination of clearance and as well as interference fit. So that is our transition fit. So you can see the first rectangle is partly in the tolerance zone of the shaft and partly in the tolerance zone of the hole. Second, the rectangle is completely within the tolerance zone of the hole, and in the third case, the tolerance zone of the shaft is slightly above the tolerance zone of the hole and partly within the hole. So that is why we get a combination of clearance and then the interference fits. In case of a shaft basis system, right, the different clearances or interferences obtained by associating with various holes and shaft dimension is kept as reference whose upper deviation is 0. Because see, when we machine the shaft, I cannot increase the diameter of the shaft. I can keep reducing the diameter of the shaft upon machining. Whereas in case of hole basis system, the lower deviation was 0, right? That is, the least diameter of the hole was kept at the 0 line, because I cannot reduce the diameter of the hole. I can keep increasing the diameter of the hole only. So that you should carefully note it. So size of the shaft is the basic size, and it is denoted by lowercase h. So this is basically used in industries for semi-finished or finished shafting, right? So this is the way we represent the different types of fits in the shaft basis system. Now can you see the shaft tolerance zone is touching the 0 line, whereas in case of the tolerance zone of the hole is well above the 0 line. I'm going to associate the different clearances or interferences only with respect to the hole now. Okay. So first case, clearly we have a clearance fit. Figure A is clearance fit, and then figure C. See, the tolerance zone of the hole is well below the tolerance zone of the shaft. So again, we need to apply external force or pressure to create the fit. And figure B obviously is the transition fit. Please take your time to understand the different types of fits from this tolerance zone representation. So how these fits and tolerances are specified? We basically use Bureau of Indian Standards. So there is a way to specify a fit and a tolerance. See, for example, a tolerance is indicated by an alphabet, either lowercase or uppercase. So uppercase is meant for the hole and lowercase is meant for the shaft, and followed by a number. We'll see what is that number mean in the upcoming slides. So the tolerance will basically have two parts. One is the fundamental deviation and another one is the magnitude of the tolerance. So what is this fundamental deviation? It actually gives us the location of the tolerance zone from the 0 line, right? So where will be this 0 line? So this we have already discussed. In case of hole basis system, the 0 line will be on the lower limit of the hole, whereas in case of the shaft basis system, the 0 line will be on the upper limit of the shaft, right? So from that point, right, where exactly our tolerance zone is located, that is fundamental deviation. So the magnitude, that number is actually the magnitude of the tolerance, okay, and we call it as a grade. So the grade of tolerance is simply a group of tolerances which are considered to have same level of accuracy for all basic sizes. So that we can see in the tolerance table in the next slides. So there are basically 18 grades of tolerances. So IT means International Tolerance Grade. See, for example, so there is a shaft of 50 mm diameter with basic size. So I want to designate the tolerance grade. If the fundamental deviation is denoted as G and tolerance with a tolerance grade of 7, it is written as 50G7. Okay, lowercase meant for shaft. You can also evaluate the tolerance to be applied for this 50 mm from the table that we will see. Okay. So here between 18 to 30 we have our basic size under E7. So minus 40 minus 61. So we have unidirectional tolerancing system. Minus 40 micron to minus 61 micron, and you have to convert that to mm. So please don't forget that. Yes, let's come back to our problem. Yes, 20 superscript, right? So minus 0.040 mm minus 0.061 mm. Now you add this 20 to the both the limits, right, to get the maximum and minimum diameter. So when will you get the maximum diameter of the bush? 20 plus 0.013. Similarly, lower limit. Similarly for the crank pin, right? So we have estimated it. Now what about the clearances? So when will you get maximum clearance between a hole and a shaft? So it will exist between the upper limit of the hole and the lower limit of the shaft. So in this case, upper limit of the bush, right, that is the hole, is 20.013, and crank pin lower limit 19.939. If you subtract, you will get, this is the maximum clearance. If you manufacture the bush to its upper limit and the crank pin to its lower limit, you will get the maximum clearance. Similarly, minimum clearance, lower limit of the bush and the upper limit of the crank pin, right? So this is the magnitude of the clearance or the positive clearance gap. Let us see the second example. So here we have a valve seat, right, where we have to have an interference fit for the assembly. So we are required to estimate maximum and minimum diameters of the housing. So the housing is actually, you can treat it as a hole, and the valve seat as the shaft. So then we are expected to calculate the maximum and minimum interferences. Okay, 20H7 and S6, you can go to tolerance table, right? So now that you know how to estimate the tolerance zone. So for 20H7, it is plus 0.021 and then plus 0.0. You have deviation on only on one side. Similarly for the valve seat outer diameter, it is 48 microns and then 35 microns. So you can calculate the maximum and minimum diameters. How do you get the interference? How do you calculate the maximum and the minimum interference? Unlike clearance. So you should understand the meaning of the interference here. The overlap, right? When will you have maximum overlap and minimum overlap? So minimum interference is possible when you manufacture the valve seat to its lower limit and of the housing to its upper limit. You will have minimum overlap, right? That is, at maximum clearance, you will have minimum overlap. And at minimum clearance, you will have maximum overlap, that is interference. So you have to take the upper limit of the valve seat and then lower limit of the housing, right? So you please take your time to understand this concept of clearance and interference. It is very, very easy. Still, if you have any doubts, you can clear that during live class. So we have come to the end of this topic, and these are the same references that I have used. Thank you.